Programmers, we're going to do part 3 of our robotics. We're going to look at some of the more complicated code. All right, before we do that, let's talk about this. Declaring a local variable is making a box in the RAM, just like making a global variable or making an instance variable. It's making a box in the RAM. The difference is it can only be used in a small section of the code. It only works in the function that it was declared inside of. And once you go in sequence order, then it disappears outside of there. Here, what am I talking about? This is what I'm talking about. So if you look down here at our play method, void play, it starts here and ends here, right? And inside of there, we declared this variable, such as int num nodes equal 14. Well, we made a box in the RAM named num nodes. The only thing that can go inside is a whole number or integer, and we shoved a 14 inside that box, right? And that exists and works great. We can use it anywhere in here, but as soon as we get here and go there, it disappears, okay? Unlike a global variable or an instance variable, such as, so this was made in the global variable or the instance variable declaration area. This one lasts forever and it works everywhere, okay? Lasts everywhere, lasts forever, works everywhere. This one only works inside the method that it was created in, and it disappears as soon as I get to right there. It disappears and goes away, okay? All right, let's go back. Let's go over here. Now we're going to use an array. So a variable is like a box in the RAM that holds one thing. An array is like a box in the RAM that holds a bunch of other boxes that hold stuff. So it's like a table. So instead of holding one thing, it can hold a bunch of things. Now, let's say we said string names. Well, this array would be called names. This guy's name names, this guy's name names, this guy's name names, this guy's name names, right? Well, how can I tell this guy from this guy if they're all named names? Well, because this guy has an index number of 0, 1, 2, 3, 4. So this guy's name is names 0, names 1, names 2, names 3, names 4. Okay? So an array is a table, and each element in the array has an index number. That is so clear. I said that so clearly. I hope you understand. All right. Now, you guys are going to make, well, you didn't do it. I think it was already made for you. But there's this array in here. We have character notes, and we have int frequency. So we have an array of characters, and we have an array of integer whole numbers, right? And so if we look at that, well, let's go over here. These are called parallel arrays because they match up. The C goes with 131. So when I'm playing the C note, its frequency is 131, right? And these go together, these go together, these go together. And that works really well because notes, so C's name is notes 0. So like I was saying, C's index number is 0, and 131's index is also 0. So they go together and they have the same index number. Okay, so notes D goes with frequency, or notes 1 goes with frequency 1. So D goes with 147. All right, and that works really well with a for loop, which we're going to talk about right now. So a for loop, basically, you say for, this is the structure of a for loop, but so for int I equals 0, I is less than num nodes, and then I plus plus. Okay, so the for loop goes from here to here, and it happens over and over and over again. Everything inside this loop repeats until I is less than num nodes. As soon as I gets greater than the number of notes, it kicks us out of this for loop, right? And we're going to see in a second how this works and why a for loop works really well with arrays and even better with parallel arrays. All right, let's do this. So we have this method call. We say play. All right, so we want to play, and we're going to say, well, what note do you want to play? I want to play a G. How many beats is that? That's going to be 2 beats. All right, so we jump down to my void play. This, by the way, this code is crammed together so you can see it all together. So we say void play character is note. All right, so note is equal to G. So we have our local variable named note, and we just said, oh, character note, we just sent it a G, so now note is equal to G. And int beats is equal to 2, which we don't really care about beats that much. All right, and then we say int num notes equals 14. So it's right there. We're going to just remember this box is num notes is holding 14. All right. So let's jump down to our for loop. So it's like, oh, we're going to start a for loop. Int I stands for iteration. So we have this local variable I. Now we just created it. And it is equal to 0. This is going to control how many times or how many iterations we go through the loop. And then we say, hey, are we going to go through the loop? I don't know. Let's see. We're going to go through the loop as long as I, which is 0, is less than num notes, which is 14. And the question is 0 less than 14? Yes, it is. So we're going to jump into our loop. And so inside the loop, it asks this question, hey, we're going to keep going if notes I, well, what's I? Oh, I is 0. Okay, well, what's notes 0? C. Okay, so, hey, is C equal to note? Well, what's note? Oh, we just said note was G because we sent the G here, and now it's here. So is C equal to G? No. Okay, C is not equal to G, so what are we going to do? We're gonna skip this. Okay, we're not going to do this, and we're going to jump back up to the top of our loop. Okay, and we actually do this first, or we do this next, I plus plus. Okay, so now I plus 1. So 0 plus 1 is 1. So we're going to change I now is to 1. All right, this is our iteration. So I is equal to 1, so we go 0, 1. So it's our second, even though this is a 1, that means it's our second iteration through the loop. All right, so we say, is 1 less than 14? Yes, it is. And so we're going to jump down here and we're going to say, hey, is notes I, which is now 1, is notes 1 equal to note, which is G? Is notes 1, is D equal to G? No. So we're going to skip this, hit here, is going to bump us back up here. So we say I plus plus, so now I goes to 2. All right, so I is now equal to 2, and so we're going to say, well, is 2 less than 14? Yes, it is. And is notes 2, E, equal to note, which is G? No, it's not. And so we're going to go through, we're going to go to 3, and then it's going to go. So like we said, it's going to go through and to go to 3. Hey, is F equal to G? No. And it's going to go to the next one to 4, and so let's say that I is now equal to 4. Is 4 less than 14? Yes. So we're going to jump down here. Is notes I, which is 4, so notes 4, is G, so it's going to say, is G equal to G? Yes, G is equal to G. Okay, great. So now we're actually going to finally do this thing. Well, then the current frequency equals frequency I. Well, what's I? I is 4. Well, what's frequency 4? 0, 1, 2, 3, 4, 196. So we're going to say current frequency equals 196. So in our local variable, we put in this 196. All right. So that's basically what we're trying to get to, is we're going to try to match up with G to this frequency 196. So now we finally, so we're going to go through the loop a bunch more times until we get to 14, right? So we're going to go through, is 13 less than 14? No. Is 14 less than 14? No. So it's going to eventually kick us out of this loop, and then we're going to jump down to this line of code, and it's going to say, hey, we're going to play a tone. And it's going to say, well, what pin are you going to play on? Oh, speaker pin, which is 10. Okay, we're going to place a tone on speaker pin 10. And it's going to say, what's the current frequency? Well, the current frequency is 196. So we're going to play 196 for 2 beats. So we're going to say, burp. And that's how this whole thing works. All right, so the question is, why does a for loop and parallel arrays work really well together? Because we can use the I to control how many times we go through the loop, right? And it increments 1 each time. And that allows us to go through our array and say, hey, does this one match this? Nope. Does this one match this? Nope. Does this one match this? Nope. Does this one match? Does this one match? Yes. And then so we do something with this. And like, as you saw, we do something with this. So it allows us to go through and look through all of the elements of the array. Hopefully that was clear as mud. Okay, so make sure you take those notes. Make sure you show me your working project, and get me to sign off on lesson 2A, the regular part, before you go on to the coding challenges. Make sure that you do the coding challenges. And there you have it. Audio.